Let's talk about finding the zeros of a function. Now, the good news about finding zeros is that you guys actually already know how to do this. Yes, zeros are simply another name for the x-intercepts. For a function f of x, the zeros are the x values in the domain of the function for which f of x is equal to 0. Graphically, this is where the function crosses the x-axis, also known as the x-intercepts. As you guys already know, to find the zeros of a function, or the x-intercepts of the function, we want to set the function equal to 0. This means that we are substituting in 0 for y. Yeah, we did that in the last section, okay? So the process is exactly the same. Substitute in 0 for y, that's the same thing as substituting in 0 for f of x, and solve the equation. It is the exact same process as finding x-intercepts. So let's do an example here. Find the zeros of the function algebraically. Check your work using a graphing utility. All right, our function is f of x is equal to 3x squared plus 22x minus 16. Again, all we are going to do is set the equation equal to 0. Right? Plug in 0 for y. That gives us 3x squared plus 22x minus 16 is equal to 0. Now, as we've said before, whenever you guys are dealing with quadratic equations and trying to find the zeros or roots of a quadratic, you should think about factoring. Take a second to try and figure out what this is going to factor into. Notice that the first terms have to multiply to give us x squared. The last terms in each binomial have to multiply to give us negative 16. And when we FOIL or use the distributive property, all right, our outer and inner terms have to add to give us positive 22. This ends up factoring into 3x minus 2 times x plus 8. Notice if we were to FOIL this out, 3x times x gives us 3x squared. 3x times 8 would give us plus 24x. Negative 2 times x gives us minus 2x, leaving us with 22x. And negative 2 times positive 8 leaves us with negative 16. All right, you might have had to do a little bit of guess and check with your factoring there, but definitely works out. So after we factor, what do we do with each factor? We set each factor equal to 0 and solve for x. Setting the first factor equal to 0 and solving for x gives me x is equal to 2/3. And setting my second factor equal to 0 and solving for x gives me x is equal to negative 8. Now, if you had a tough time factoring this, another option for finding the zeros of a quadratic is to use the quadratic formula. X is equal to negative b plus or minus the square root of b squared minus 4ac, all divided by 2a. All right, using this formula, plugging in for each one of the constants, notice a is the constant that comes in front of the x squared term, that would be 3 in this case. B is the constant that comes in front of the x term, which would be 22 in this case. And c is the constant that comes on the end, which is a negative 16. Plugging that in would give you the exact same answer. Now, personally, I think the factoring is a little bit easier than working with the quadratic formula here, but if you have something that doesn't factor, the quad formula is going to be your next best bet. So, check your work using a graphing utility. Yeah, pull out your TI-84 calculator and graph our function y equals 3x squared plus 22x minus 6. You should end up with a parabola that looks like this right here. And notice, where do our x-intercepts or our zeros occur? They occur at x equals negative 8 and x is equal to 2/3. Make sure you guys are comfortable finding x-intercepts or zeros on your calculator. All right, for the TI-84, you are going to hit second calc 0 and follow the directions to input a left bound point, a right bound point of 0, and hit enter. All right, if you have any questions on that, if you've never done it before, see if you can find a quick video on YouTube on finding zeros on your calculator. If you still have questions, come and see me. All right, let's take a look at another example. Find the zeros of the function algebraically. Check your work using a graphing utility. G of x is equal to the square root of 3x plus 2. Again, to find zeros, to find x-intercepts, we set y equal to 0. Set the equation equal to 0. The square root of 3x plus 2 is equal to 0. Now we just have to do the algebra out to solve for x. Our first step here is going to be to square both sides of the equation. Notice I have a square root. The inverse operation of taking a square root is to square. And again, in algebra, whatever I do to the left-hand side, I have to do to the right-hand side. The nice part is that squaring the right-hand side still leaves us with 0. And next, to isolate x, I would have to subtract 2 and then divide by 3, leaving with my final answer, x is equal to negative 2/3. Again, take out your TI-84 graphing calculator and plug this into your y equals. We have y equals the square root of 3x plus 2. You should end up with a graph that looks just like this, right? And make note, yes, where does this intersect our x-axis? Right here at x equals negative 2/3. Couple more. Find the zeros of the function algebraically. Check your work using a graphing utility. H of x is equal to 2x squared minus 8 divided by 3 minus x. Well, as we've done in the past two examples, set y equal to 0. Set the equation equal to 0. Okay, so I have this fraction is equal to 0. One thing to make note of is that a fraction will only equal 0 if the numerator is equal to 0. And also recognize the first step here, algebraically, would be to multiply both sides by 3 minus x. Well, what happens when you multiply the right-hand side by 3 minus x? You still end up with 0. All right? So a shortcut is to simply take the numerator, if you have a big fraction, take the numerator and set the numerator equal to 0. Again, the only time a fraction will ever equal 0 is if the numerator is 0. But this part's also important given that the denominator is not also 0. Okay. So we have 2x squared minus 8 is equal to 0. To solve for x, we would add 8 to the right-hand side and divide by 2. That leaves us with x squared is equal to 4. And now I have to take the square root of both sides of my equation to solve for x. And remember that whenever you take the square root of a variable, you must include both the positive and negative roots. This leaves us with x equals 2 and x equals negative 2. Now, one thing to be careful of when you are dealing with fractions like this is that you should always plug your zeros back in and check your work. Notice that plugging in 2 for x is going to give us 0 divided by 1. And 0 divided by 1 is 0. 0 divided by any non-zero number is going to be 0. We could also check our work by plugging in negative 2. Plugging in negative 2 into my function gives me 0 divided by 5. Again, that equals 0. That will tell you that those are both correct solutions. And then we could verify that graphically, right? If you were to plug this into your calculator, one thing to make note of when you plug this in your calculator, just put parentheses around the entire numerator and the entire denominator. We get our graph. This is what our curve looks like. And notice we have x-intercepts at x equals negative 2 and x equals positive 2. All right, let's try one more with a big fraction. Find the zeros of the function algebraically. Check your work using a graphing utility. So, what was our trick? Again, we set the equation equal to 0, but when does a fraction ever equal 0? Only when the numerator is equal to 0, given that the denominator is not also equal to 0. So we set the numerator equal to 0. X squared plus 6x plus 5 is equal to 0. Again, we have another quadratic equation. How do we solve quadratics? By factoring. This particular quadratic factors into x plus 5 times x plus 1. Solving the quadratic equation for x gives us x is equal to negative 5 and x is equal to negative 1. Now, as we said, always a good idea to check our work, especially when we are dealing with big fractions. Let's go back and plug these values of x in. Here we have x is equal to negative 5. Well, plugging in negative 5 for x gives me 0 divided by negative 4. And 0 divided by negative 4 is 0. This first solution checks out. Yes, that will definitely be an x-intercept. Now, let's test this second solution that we found. X is equal to negative 1. Plugging in negative 1 for x gives us 0 divided by 0. This is problematic. As we've talked about many, many times, all right, we cannot divide by 0. Dividing by 0 is undefined. And because that gives us an undefined value, this is not actually going to be an x-intercept. It can only be an x-intercept if it equals 0. Notice that plugging in negative 1 into our original function does not equal 0. It actually equals undefined. So in this case, there is only one x-intercept. And you could verify this graphically. Again, take out your calculator, graph this function in your calculator, put the entire numerator in parentheses and the entire denominator in parentheses, and we end up with a graph that looks like this. Notice that there is only one x-intercept. It occurs at x equals negative 5. The one thing that you might not be able to see on the graph is that this function actually has a hole in it when x is equal to negative 1. All right, one thing to keep in mind, again, all right, another thing to keep in mind. Yes, lots of things to keep in mind. All right, we're going to talk about this a lot later on in the year. If we have a fraction and end up with 0 divided by 0, what that means is we are going to have a hole in the graph for that particular value of x. Okay, so again, we might think that x equals negative 1 is a solution, but when we go back to plug it in and check to make sure we get out 0, we actually get undefined. Right? X equals negative 1 is not in the domain of the function, and therefore it cannot be a 0 since the function is undefined. All right, there you have it, finding zeros or x-intercepts.